We have seen the derivation for F is equal to m into A. But what does it actually mean? Well, it's quite simple. If I push something harder, it will accelerate more. That is, it will speed up faster, is it not? It's quite simple. So we'll see this experimentally. So here we have an experiment. The procedure is quite simple. Set up the experiment as seen in the picture. The setup is a bit complicated. I'll make a separate video explaining this so that you guys can do it at home. So we have a car. And we have sensors over here, and there is a mass. Okay, let me explain how it works. So the car is attached to the mass through a thread. And there is one more mass over here which you are not able to see. But it is to help stabilize. So there is two masses, mass 1 and mass 2. Mass 1 is bigger than mass 2, so you guys can ignore this. It's basically mass 1 pulling the car to the right. So the sensors will help find the difference in time, right? See, when the car moves from one point to another point, it takes some time. So the sensors will help us measure that time factor, and the system will calculate acceleration and speed for us. Right, so this is your Python code running in the background. So the sensors over here, so these are your sensors. It will help us find the time difference and thus help us calculate the speed and acceleration of the car. So how is that we're going to do this experiment? So this is the setup. This is my hand. When I do let the system go, right, the mass will pull the system down, the car down that is, and the sensors will pick up and the system will calculate the time difference and also the acceleration and then the velocity. So we are going to understand this particular formula or expression or proportionality by changing the mass. So mass 1, it would be 40, 60 and 80 grams. So by increasing the mass each time, we need to look at the acceleration and speed value. So by doing so, we get to understand this formula better. So set up the experiment as seen in the picture. Note down the net mass pulling the toy car. So in each of this case, I have the net mass that is given before the experiment. Observe the final velocity and acceleration attained by the car. That is, with the help of Python code, you need to do that. Change the net mass that is pulling the cart and repeat step 2 to 4. So we need to change the mass. So one set is 40, another time it's 60 and 80. So by doing the same thing repeatedly but different masses, we get to observe this. Okay. So please have a look at this video. Quite simple. When you get to see that, you will understand better. I hope you guys made a note of the speed and velocity and time factor over there. If not, please watch the video again, the experiment part, and make a note of it. Okay, I hope you guys did it. So what is that we observed? Quite simple. With change in mass, we're able to observe this set of final velocity and acceleration. Okay. So here I have a net force of 0.4. Here it's net force is 0.6. And this is 0.8. How did I get this value? See, in the next chapter, we'll understand that F is equal to m into g. We already understood that F is equal to m into A. But here it's m into g. Why g and how g and all of that we'll understand in time. So this particular mass will apply this much of force. Okay. So this mass is applying this much of force. How? We'll understand in the next chapter. Okay, so these are your forces. Forget about how we got this value, but these are your forces, that I can promise. The final velocity attained in the first case is over here. The final velocity is 0.6935, so on and so forth, approximately 0.7. Second one, final velocity is 0.985. 0.985. In the third one, final velocity is 1.16. Acceleration is 0.69 in the first case. Second case it is 0.98. Third case it is 1.91. Okay, I think I got it right. Yes. No, this was wrong. 1.39. Right, now the main conclusion. See, doing all of this is, yes, important as well, but interpretation of data is more important. Because of this, we get to derive a formula. See, it's not the formula which came first. It is the experiment which comes first and then the conclusion. Since we know the formula, we are able to do the experiment telling that, okay, we're going to understand this. But if you're doing a research, it's always the experiment which comes first. So when you do an experiment, you will have some data, and interpretation of the data is where your IQ comes into picture. Now, what is that we observe? I have a force, and in the second case, I increase the force, right? So from a force of 0.4, I increase it to 0.6. What do we see in terms of acceleration? It increased. If I increase force a bit more, what happens? It is accelerating even more. So what is that we can tell? If I happen to have more mass over here, the car would have moved further and faster. Is it not? It will accelerate faster. It will speed up faster, that is. It will accelerate more. Right? And that's what the formula tells. Force is equal to mass into acceleration. If not, acceleration is proportional to force. And to conclude all of it, we have this. When an unbalanced external force acts on an object, its velocity changes. That is, it accelerates. The acceleration is directly proportional to the applied force for a fixed mass. See, mass of the car is not changing. What we are changing is the force with which it's been pulled. So basically we saw that as and when we increase the mass, we get to see that the system would move faster. As simple as that. Okay. So now you guys have to pause, think about what you learned, and make a small note of it. So you need to write the heading and the conclusion. In between, whatever else you guys want to write in terms of picture, in terms of written format, in your own language, whatever it is, it doesn't matter. Write it in a way wherein you understand when you read it a month later. Got it? Okay, so please pause and you can have a look.